All right, well, thanks for coming, everyone. Thanks to the Linux Foundation for putting on this awesome conference, flying me out, get to talk to you guys. Thanks for coming and to listen to me ramble for the next 20 minutes. I really appreciate that. If you haven't guessed, I'm going to be talking about server-side rendering. Yeah, server-side rendering. It's a really good thing. So, well, we'll just go on. Before I begin, a little bit about myself. My name is Matthew Phillips, and if you can't tell from the accent, I'm from Kentucky. I do wear shoes, just so you know. You can follow me on Twitter, which you should do. I expect that my Twitter followers will be like doubled after this, hopefully. Yeah, I'm a JavaScript developer, believe it or not. I work for a company called Bitovi, where we do a lot of different stuff. But one thing that we do is we do a open source client-side framework called Node.js. And part of working on Node.js, I developed a server-side rendering solution for that called CANSSR. So a lot of what I'm talking about today is revolving around my work with CANSSR, but I'm not necessarily talking about my project. I will pimp it a little bit, but mostly I want to talk about the experiences, the things I've learned from developing this. So I guess the takeaway would be things that can help with providing a better server-rendered experience for your users. All right, there's a few terms you should know. You've probably heard of a lot of these, but if not, that's okay. I'll probably be saying some of these myself. Shared code base, isomorphic, universal. This is a newer one that people are using. I kind of like that one, universal. If you haven't guessed, these all mean pretty much the same thing, which is that single code base which runs in both the server and the client. That's the goal of server-side rendering. Before we get too deep into what server-side rendering includes, you first have to ask the question is why bother? Why even do server-side rendering, right? Sometimes some people think that it's not actually necessary, but there's some compelling reasons to do so. The most important reason, I think, is just perception, right? The perception that your application is fast. If a user goes to your website and they see a spinner, their perception is that your application is slow. So there's a lot to be said just for that single point. SEO is important as well. Well, SEO is not important, but if you think it is important, then you probably want to do server rendering. Googlebot can execute JavaScript, so it doesn't need your application to be server rendered, supposedly. But the extent to which it does that and whether or not other search engines do that is kind of an open question. So it's a good thing to do. If you care about money, then you probably should do server rendering. I care about money. Amazon has found that their conversions actually increase by 1% for every 100 milliseconds they can take off the initial page load. So think about that. That means if it's 1% increase for every 100 milliseconds they take off, the inverse must be true as well, right? That must mean that for every 100 milliseconds slower the page loads, conversions decrease by 1%. So something to take into consideration. All right, well, let's talk about the state of server-side rendering and what server-side rendering kind of has looked like in the past few years. When I started working on CANSSR, one thing that I started off doing what most other frameworks do, which is you provide them some type of template. Most client applications are essentially a template, right? So you provide them a template, they render it, and then the rest is up to you. You got to figure out what to do with that result, the HTML. So I started off doing this and kind of quickly realized that this was not really enough. Hence the title, server-side rendering is not enough. There's a lot more to it than just rendering a template. So I came to this thesis, very original picture, I don't know. Everything should be server rendered. So anything that can be server rendered should be server rendered. And there's a lot more than you would expect. So the rest of the talk is just me trying to convince you of of how you can make your application better by rendering more things on the server than you probably are doing today. I came up with a set of requirements, things that I do think are very important to having a good server rendering experience. These can be categorized into two main categories: performance and maintainability. Performance are things that matter to your users. These are things that your user is going to notice when they go to your application. Maintainability, not such a big impact on your users necessarily, but it will have a tremendous impact on yourself. And you know, as an effect, it will affect your users, because the more maintainable your application is, the more features you can add that help with your users. All right, so let's go through some of these. On the performance side, there is rendering speed. Obviously, you need your application to render as quickly as possible. You want to handle as many requests as your server can take. Only including the assets that are needed for a particular request. So you think about the way that we typically develop client-side applications is that we just bundle all of our stuff into one file. We put all of our JavaScript into one file. We put all of our CSS into one file. But if you have a large application, that's not really the best approach. So limiting the number of assets for a particular request is pretty important. And then preventing unnecessary requests. Remember, these are isomorphic applications. They run on the client and the server. So if you're doing API requests on the server, you don't want to do those again on the client. So handling that is important. On the maintainability side, having a shared router. I know it seems like kind of obvious, but it's kind of a big thing, right? You don't want to have to maintain two sets of routing tables for what is actually the same application. Asynchronous rendering is a huge advantage to have. And then this is kind of a fun one, but if you've ever used hot module swapping, if you use a module loader that supports that, it allows a very instantaneous development experience. I'll talk about that here in a minute. Okay, let's go through each of these and kind of talk about what they mean. The first is rendering performance. This is very obvious, but you need to handle a lot of requests in your application if you're going to build something that scales. So to get rendering performance, travel back in time a little bit, back to the early days of Node. And we used to do server rendering in what's called a headless browser. If you don't know what a headless browser is, you've heard of Phantom.js. This is the most popular example. A headless browser it's literally a browser. It doesn't have the Chrome. You can run it on your server. So what we used to do back in the day was we would put these instances of Phantom on our server. We would tell it to open a particular page in our app, just like you would in a browser, and then we would scrape the result and send that along. It's worked decently actually, but it had some drawbacks. It consumed a lot of memory. It's actually a browser, right? Browsers are pretty hefty. You need to pull it because you're going to handle a lot of requests in your application, and you can't render as quickly as requests can come in. So you need to have some type of way to pull multiple workers to handle all these different requests. So these two points together kind of made scaling a bit difficult. It was pretty fast though, so there's that, I guess. Virtual DOMs came along a couple years ago. Virtual DOMs have been like a tremendous boon to server rendering. It made it much easier than it has been in the past. It's really opened a lot of opportunities. The biggest of which is that you can run the same code on the server and the client. I'm going to keep saying this over and over, but you want to run the same code on the server and the client. Virtual DOMs enabled this because they didn't have any dependencies the way that a typical jQuery app has a dependency on the document object. Virtual DOM libraries do not have that dependency, so it made it so that you could easily run the code in both contexts. They would run within a single node context. What I mean by that is that you'd only have one node process. You wouldn't have to spawn multiple processes to handle each request. One downside is, it's not showing up quickly. Oh, okay, it's fine. Rendering is usually synchronous. That kind of sucks from a maintenance standpoint. I'll get into that a little bit more here in a minute. KNSSR, this is the library I work on. We have a virtual DOM as well. Our virtual DOM looks like a real DOM. What I mean by that is that it has a document object, it has document create element, it has nodes and text nodes and comment nodes and all of the normal API that the DOM has. But it only has like a little bit of it, only the basics. So that was the way that we chose to implement it. The advantage of that is that it's very compatible with legacy code. I would love to demo if I had more time, but you can run jQuery apps very easily. You can run Bootstrap and stuff like that. All right, minimizing request size. This one is hugely important, something that you probably don't think about normally, but what I mean by this is that you only want to include the assets that are needed to render a particular page. So if you're rendering, and let's move on to an example, rendering the cart page, you don't want to include the CSS for like your product page or your search results page, right? You only want to include the CSS needed for that particular page. So the traditional way is to load your CSS through a module loader. Like if you ever use Require.js, it has a CSS plugin which loads CSS. If you use Webpack, it has the same thing. They all work more or less the same way. What you get is, and this is, we call this traditional method, is that initially the page is unstyled. The JavaScript kicks in. It starts to load CSS. It will load like a header and like in this case a header and a sidebar. This is kind of your main, your site-wide style, kind of the skeleton of your site. And then it will finally render the page-specific styles after everything is completely loaded. All right, this obviously is not what you want. So what a lot of people have done is started to just manually include that CSS into your server template. You have a server template. You know that you're going to load main.css. So just go ahead and stick that into your template. But the result of there is that initially the page is partially styled. So maybe that's like a little bit better. The main CSS is included, but then the rest has to be progressively loaded. So what CANSSR does is it actually just sticks everything into the document. It renders everything right away. So all styles are included. So in this example, the head of the document will include main.css and it will include cart.css. So it's something that CANSSR gives you. There might be other libraries that do this, but I think we do it very well. What this enables is like component-based architecture. Component-based architecture is a way to organize your application where every component will import all of its own dependencies. So if you have a component which has a particular style, it will import its own style. So if we enable this with CANSSR. All right, minimizing the number of requests. What I mean by this is that if you have a isomorphic application, it runs the same code in the client and the server. When you do server rendering, you're going to make all the same API requests you make in the client, right? But so you don't want to make those again when we're going to do server rendering. It's going to get to the client. The user is going to see the fully rendered page. We don't want to then go back when the JavaScript kicks in and make all the same API requests. So I call this preventing redundant requests. And the way to do this is just to embed the response data into the page. In this example, this is how we do it in CANSSR, is that we insert a script tag with a global variable. We're calling it inline cache. You can call it whatever you want, but the point is that this will be all the data from all of our API requests. And so when you go to render in the client, you can use this data as your initial data to do the initial rendering. So that way you don't have to do the API request. Shared code base. So one thing to think about when you're developing your application is just how much code is shared. Obviously not all of it, but as much as you can minimize the differences, it'll help with your maintainability. So are you using the same template engine on the client and the server? If you're using the client side framework, you probably are. Does your main run in both contexts? In other words, can you require your main and do stuff with it? Do you have a shared router? This way you don't have to add new routes manually in two separate places, right? You can just have one file which maintains all of your routes. This is an example of using CANSSR. It's very simple. This is with Express middleware. You just directly require CANSSR middleware. You create an Express app and then you use the middleware. That's it. There's no defining of any routes or anything like that. This is the core API. This is the lower level API. You can require can SSR, call SSR, which creates a render function. This render function can take any URL. This is all through if you're using Node.js. Or you can also pass it a request object, and it will respond with the result. So it's pretty simple to use. Can SSR expects your main looks like this. This is a JavaScript. This is your JavaScript main. It has two functions it expects. It expects a create state. Create state is an object which takes the node request and it returns an object. This is where you would use your router to take the request URL and create some state off of that. It also expects a render function. Render function takes a document and that state object that was created. So the document on the server is we're going to create a new document for each request. And so we're going to give you this document, and you can do whatever you want with it. So in this example, this is like a little jQuery app, which is appending a title, and it's rendering a template, and then it's using like bootstrap tabs. That's what's happening here. Asynchronous rendering is like my favorite feature of can SSR. What we mean by this? Well, let's talk about synchronous rendering and kind of the downside to doing it that way. This is two files that you'll have. You can probably guess what fancy framework is, but so we have a server.js, which this is where we're handling our routes. Cart.js is a component. You notice that Cart.js expects to get the cart data. So what we have to do is we have to actually, because this is rendered synchronously, it forces you to fetch all the data on the server before actually doing rendering. This means that you can't use component-based architecture, right? So you can't create a cart that fetches its own data. You have to fetch the data outside. So you have to move all the application logic to like another layer. So this makes it really hard to write reusable components, right? Because you can't write a component that fetches its own data. So yeah. We actually, can SSR can load React and do rendering asynchronously. It's pretty cool. That's all based off this library can wait. Will this load? No. Screw it. Let's move on. All right, instant dev workflow. This is the fun one. This is hot module replacement. Hot module replacement is this is supported by, we support in Node.js, Webpack supports this. What this means is that when you can make changes to your code and they'll instantly show in the browser. We support this in both the server and in the browser, so it's a nice feature to look for. All right, takeaways from the talk. Only include the JavaScript and CSS you need for the request. Include any API responses into the HTML. This way you can reuse that for the initial rendering. Use a router that works on both sides, and use component-based architecture in asynchronous rendering. That's all I have. Questions?
So are you not including, or are you including all of the CSS in the head? Or
Yes.
are you including links to the CSS reference?
Links to the CSS, yes.
So isn't that causing more trips to the server?
It's not causing more trips to the server. It's causing the same amount that would normally be. You could put it all in a style tag. You could do that technique. I mean, I don't know. That's like, then you're making the HTML be bigger, right? So there's like plus or minus to doing it that way.
Why is CMI cache below the
I'm sorry, I didn't hear you.
Why is CMI cache below the variable?
Well, because it can't be a local variable because you need your code to have access to it. So we're just putting that into a script tag. It's going to have like a stupid name that doesn't mean anything, so you can get rid of it afterwards. But so that your code actually is able to use it to do the rendering. Anything else? No? All right. Well, you can come talk to me if you want to. Thanks everyone for coming.